Okay, and welcome to the second section of our 1-2 lesson, the angle addition postulate. Now, I want to start this by, we'll just call this example 1, sure. And I want to draw two structures that are very, very common in geometry. So, structure number 1 is going to be two rays. Remember, a ray is a line that comes from an endpoint and goes out. And, of course, whenever you have two rays, this forms an angle. But in specific, this is a special angle. It is a 90-degree angle. And then our second structure is going to be a straight line. And I know a lot of y'all don't think of a straight line as an angle, but it is. It is actually a 180-degree angle. Now, the reason why we're going to look at these two structures, a right angle and a straight angle, is because what happens if I draw a line here, and what happens if I draw a line here? Well, what I've essentially done is I've split this into two angles. So I'll call this angle 1 and angle 2. And for labeling's sake, I'm going to call this one angle 3 and angle 4. So what does the angle symbol look like? Well, it kind of looks like a crooked less than symbol. And here we could say angle 1 plus angle 2 is equal to 90 degrees. Remember that a right angle is 90 degrees. And this brings us to our second diagram. Here we have angle 3 plus angle 4, and this adds up to be 180 degrees. And these two scenarios have two special names. Whenever two angles or three angles or four angles, it doesn't matter the number, add up to be 90, we call this COM, complementary, or complementary. Alright? So whenever two things add up to be 90 degrees, they are complementary. Alright, how about when they add up to be 180? Well, that's called supplementary. Supplementary. Sometimes it just won't write, I guess. But what does this look like in practice? Well, what if I was to tell you that angle 1 is actually equal to 38 degrees? Could you find angle 2? Well, of course you could. If the segment addition postulate says that one part plus another part equals the whole, well, it also applies to angles. Here we have one part plus another part equals the whole. In this case, the whole is 90 degrees. And remember, whenever you have the whole and a part, you should always subtract. So if we're to do 90 minus 38, which I believe should be 52 degrees, well, there you go. We can say angle 2 is equal to 52 degrees. What about right over here? What if I told you angle 3 was in fact 110 degrees? And I asked you what is the measure of angle 4? Well, angle 3 is a part, and we know that this, the 180, is a whole, and so of course we can simply do 180, the whole, minus the part, 110, and of course that would give us 70 degrees, which would be our angle 4. Okay. Pause the video, finish taking any notes that you need, and we're going to move on to our second example. Okay, so here we are, example 2. We're going to start adding in just a little bit of algebra. Okay, so let's say we have this scenario. We have clearly a right angle, so we know that these two angles should wind up being complementary. And let's give them some labels. Here we have point A, point B, and this is also special. When two rays or two line segments meet, we call this a vertex. When there's multiple, we call them vertices. And here's going to be our point C, and here's going to be point D. And let me give you some information. Let's say that angle A, B, D, so this is how we write angles when we want to denote them using letters. A, B, D, we go from A to B to D, is going to equal 2x plus 6 degrees. And then let's say that angle ABC is equal to, well, actually, you know what? We know what angle ABC is equal to because it's 90. So let me just change this. Let's call this DBC. There we go. Angle DBC is going to equal, say, 26 degrees. Well, if I want you to find x, what would we do? We know that angle ABD is this right here. That is a part. And we know the angle, remember I'm changing that to D, angle DBC is this part. And for the angle addition postulate, we know that the part plus the part is equal to the whole. And so here we can simply say 2x plus 6 plus 26 is equal to the whole. And in this case, since we're given it is a right angle, we know that our whole is going to be 90 degrees. Now, this is going to require some algebra. The first thing we want to do is combine our like terms. So ask yourself, what is 6 plus 26? Well, 6 plus 26 is going to be 32, which is equal to 90. Now from here, we're going to do just some very simple solving. Remember, in order to get the x by itself, you first must always get rid of the addition or subtraction. So minus 32, minus 32. Remember, the opposite of addition is subtraction. And those two things cancel out. That's why we subtract 32. So I'm going to bring this over this way. And here we have 2x is equal to 90 minus 32, which will give us 58. And lastly, remember, whenever you have an x or a variable next to a number, these two things are being multiplied together. So here we have 2 times x. And ask yourself, what is the opposite of multiplication? Well, it's division. And so we have 58 divided by 2, which would in fact give us 29. Alright? And so it turns out that x itself is equal to 29 degrees. I would encourage you to pause this video, finish taking notes, and let's move on to our third and final example. Okay, here we go, example 3. And so in this one, I'm going to give you something that's a little funky. I'm going to give you this obtuse angle coming out like this, and let's give it some letters. A, B, you know what, let's call this G, and let's call this W, just so we can switch it up a little bit. And let's say I give you this. I give you that angle A, B, G is equal to 4x minus 6 degrees. And let's say I give you the angle G, B, W is equal to, say, 2x plus 7 degrees. And lastly, let's say I give you the angle A, B, W is equal to 160 degrees. Now the first question I want to ask you is, can you identify which of these 3 angles represents the whole? Which of these 3 angles represents everything? And if you said it was the 160, you are correct. So, by our angle addition postulate, we know we can take this one part and we can write 4x minus 6 plus, because it's the angle addition postulate we're adding, 2x plus 7 equals the total, or the whole, 160. Now from here, we're just reviewing some simple algebra. So, I look at my 4x, and I ask myself, are there any other like terms that have an x? And here we have 2x. So what is 4x plus 2x? Well, that would combine to be 6x. And then, what is negative 6 plus 7? Remember, always include that symbol in front of the 6. Well, of course, that would be plus 1. And that will give us 160. Now from here, remember, as we're just kind of relearning the algebra, in order to get rid of, or in order to get the x by itself, we have to first always get rid of our addition or subtraction. So how would you get rid of a plus 1? Well, minus 1. What we do to the left side of the equal sign, we have to do to the right side. And we're left with 6x equals 159. Now from here, we can divide both sides by 6. And this is actually fairly cool. 159 cannot be divided by 6, so far as I know. Let me double check myself. 1 plus... Oh, you know what? Actually, it might be. Huh. Here, let me grab my calculator. Let me just go ahead and do this real quick. So 159 divided by 6. And this will actually reduce to 53 over 2. So it couldn't be divided by 6, but it could be divided by 3. And so that would be our answer, 53 over 2. Or if you got the decimal would wind up being 26.5. And I will accept either. Alright? I hope that these 3 examples help you out. And I'll see y'all in our last section. Thank you.